Hello students, welcome to Toppscholars, the smart learning app. In today's class, we are going to solve a few questions for your subject of chemistry which will help you into your JEE main examination. So let us begin. So when Ki and acidified potassium dichromate solution react, what is the oxidation state of iodine in the final product which is formed? Option A +4, option B is +6, option C is +2 and option D is 0. So here let us look at the reaction. We can see that your potassium dichromate is getting converted into 2Cr3 plus 3I2 and 7H2O. So Cr2O72 minus is converted into your Cr3 plus. Therefore, this particular element is acting as an oxidizing agent. And here also we would see that your iodide is converted into your iodine structure. Right. So the oxidation state of iodide, as we know that it is -1, and when it is getting oxidized to the iodine structure, it is going to carry the oxidation state that is of 0. So hence the final state of your iodine will be 0. It's iodide, for iodide it's -1, but when it's getting converted into iodine, it is getting 0. So hence the correct answer is option D, which is 0. So the question is, the method which is used to obtain metals in the ultra pure state by heating with iodine and then at a higher temperature metal iodide is decomposed to give a pure metal. What is this method known as? We have 4 options. A is electrolytic refining, B is liquefaction, then we have third C option as the liquation process, and D the Van Arkel's process. So here we can say that this method which is used to obtain, what we are obtaining, we are trying to obtain a ultra pure state of that particular metal, and to obtain the ultra pure state we are heating it with iodine, right, and then we are decomposing it with the metal iodide at a very high temperature. So this method that which we are performing, that method is known as Van Arkel's method. So in this method, Van Arkel method, let's say we are using it for refining the titanium. So there is a volatile iodide which is used of the titanium and it is heated with the help of tungsten filament. And as we already know, we are using really high temperature. So it is heated at temperature above 1700 K. So pure form of titanium is going to get deposited onto the filament, and as the deposition goes on, the current is steadily raised to maintain that particular high temperature for constant deposition. Okay, so here the correct answer will be option D, that is the Van Arkel's process. The next question here is, we have an assertion and a reason statement. So the assertion statement says, during the diazotization of aryl amine with sodium nitrite and hydrochloric acid, and excess of hydrochloric acid is used. The reason for this is, excess of hydrochloric acid suppress the concentration of free aniline available for coupling. Let us look at our options. Option A says both assertion and reason are correct, and reason is the correct explanation of the assertion. Option B is both assertion and reason are correct, but the reason is not the correct explanation of assertion. The C option is assertion is correct but the reason is wrong, and the D option is assertion is wrong but the reason is correct. Let us look at the answer. So when we are talking about the reaction, that is a diazotization of your aryl amines, now this is done with sodium nitrite and the hydrochloric acid. So what happens is, the hydrochloric acid is used in surplus or it is used in higher amount primarily to suppress the concentration of free aniline, right, because in this reaction the free aniline will be produced, and to suppress the concentration of free aniline, excess amount of hydrochloric acid is used, and if it is not done, then there will be the coupling reaction observed because free aniline is available for coupling. So excess HCl is used to convert this free aniline to aniline hydrochloride. What will happen elsewise? Free aniline is going to undergo a coupling reaction with benzene diazonium chloride. So to avoid this reaction, excess amount of hydrochloric acid is added to convert these free aniline to aniline hydrochloride. So here the correct answer is our option A, because our assertion statement says that during this reaction of your sodium nitrite and hydrochloric acid, excess of hydrochloric acid is used. And why it is used? So that we would avoid this coupling reaction and suppress the concentration of free aniline available. So both assertion and reason are correct, and our reason is the correct explanation of the assertion. So here students, the question is, how many of the following compounds are going to give us NH3 on heating? So let us look at the compounds which are provided. So the first compound is NH4NO3. Then we have NH4NO2. Then we have NH4 twice Cr2O7. The fourth compound is NH4 twice CO3. And the fifth compound is MgNH4PO4. So let us look at our options. Option A is, out of these, 2 compounds give us NH3 on heating. B says 3, C says 4, and D option says all the 5 compounds give us NH3 on heating. So let us see how we are going to answer it. So the first compound that we are going to take is NH4NO3. So if we heat this compound, so what we are getting, the resulting product, we have N2O and H2O. So this particular compound does not give us NH3 on heating. So the option 1 is not correct. So that is not the compound. The second that we have is NH4NO2. If we heat this compound, we can see that the resulting product are N2 plus 2H2O. Again, the compound does not give ammonia on heating. Then we have NH4 twice Cr2O7. If we heat this compound, we can see that the resulting product are N2Cr2O3 and 4H2O. Again, no ammonia on heating, right? So the fourth compound that we have is NH4 twice CO3. On heating this compound, we can see that it produces 2 NH3 molecules, and along with that we have water and CO2 gas, that is carbon dioxide. So with this compound, we can see that the ammonia group is released on heating. And for the final one that we have MgNH4PO4. So we are going to take 3 molecules of the compound. On heating, again we can see that it releases 3 ammonia molecules along with MgHPO4 plus Mg2P2O3. Okay, so for the last 2 compounds, we can see that on heating they produce the ammonia gas, whereas the first 3 compound does not give us ammonia at all on heating. So out of 5 we have 2 compounds. So here the correct answer comes out to be option A, that is 2 compounds which are going to release ammonia or NH3 on heating. So here the question is, which one is the least basic in nature? A. NH3, B. C6H5NH2, C. C6H5 thrice N, and D. C6H5 twice NH. So here we have to determine which one is the least basic. So if we look at the electron density which is present on the nitrogen, so the higher the electron density which is present on the N, higher will be the basicity. So here density on N is affected by the electron density. Okay, so we have various ways on which you can density on N can be affected. One is the nature of the group, that is plus I or minus I present, which is there into the alkyl group or the benzene molecule. Then we have the resonance. So the delocalization of the electron which is present on the N is also going to determine the density on the N, or will be affected by that. Then if we look at the structure, that is C6H5 thrice N, here the electron pair is delocalized to the maximum extent, right? And to the maximum extent, like how much it can be done? To 3 benzene ring, and therefore it is least available for the protonation. And as it is least available for the protonation, hence we can call that it is the least basic in nature. So hence the correct answer will be option C, that is C6H5 thrice N.